Let's begin by creating a new Unity project. Make sure it's 3D. I'm going to call mine Brengine. You can call yours whatever you like. I think this is the 7th time I've done this. All right, here we go. First thing I'm going to do is rename my sample scene. Scene 01. That'll trigger a reload. Go ahead and accept that. Now we're going to need some ground to run around on here. So I'm going to create a plane. Right click in the scene view, 3D object plane, and make sure it's at 0, 0, 0. I'm going to scale it out to 10, 10, 10. Now we got a nice big surface to run around on. I'm going to create a materials folder. And then go in there and right click, create a material. Call it green dark. Go to the albedo here and pick a dark green. Like so. Drop that on the plane. And I'll rename the plane ground. F2 to rename. There we go. Now we got a little surface to run around on. I think I'll take this directional light and move it up to Y100 just to get it out of the way. All right. Let's make a little player object so we can see what's going on here. I'm going to right click, create empty, and I'll call it player, and make sure it's at 0, 0, 0. Press F to focus. There it is. Now let's give it a little visual. So I'm going to right click on the player and create a 3D capsule and move it up to, let's have a look at this here. Move it up to 1 here. I'll set it to position 0, 1, 0, and let's scale it a bit. 0.75, 0.75, 0.75. Now we got to move it to Y 0.75. And I'm also going to right click on player and create, I'll make a little head for him. 3D object sphere. And scale that to 0.5, 0.5, 0.5, and set it to 1.75. There we go. Little primitive dude. In my materials, I'll just click on dark green or green dark, Control D to duplicate, F2 to rename, call this cyan, and use the color picker to choose a cyan. And assign that to the capsule for his body. Now we got a little dude here. Maybe I'll give him some eyes too. So I'm going to rename the sphere to head. And I'm going to right click on it and create an empty object called eyes, which I'll move out to a Z of 0.5 right on the edge of his face here. And then under the eyes, I'm going to create a little sphere. I'll scale it to 0.1. We'll rename this left eye and set the X to, I don't know what looks good. Yeah, around 0.125. And then Control D, the left eye, rename it to right eye, set its position to negative 1.5. And I think these probably need to be moved back into the head a bit. Yeah, they're fine there actually. And I'll make a black material for the eyes. Throw that on the eyes. There we go. Got a little player primitive here. All right. time to make some scripts. So I'm going to go to my assets, right click, create folder, call it scripts. And then in that folder, I'm going to right click, create a C# script, and then I'm going to call it unit. So in my game, we'll have units that are player controlled and AI controlled, but they'll have a lot of properties in common. So I want to derive them from a common base class. That way other parts of the system, they don't need to be concerned if they're dealing with an AI or a player, they're just dealing with units in general. And that way you're not special casing your player and getting into some bad habits. So let's open up this unit class here in Visual Studio. And I don't want to be able to instantiate just a unit. If you imagine a class hierarchy like vehicle, and then you have car, motorcycle, boat, you don't want to be able to instantiate just a vehicle. You want to have to specifically instantiate a type of vehicle. So I'm going to make unit an abstract class, which will prevent it from being instantiated on its own. And it's really only a base class. When we're defining a base class, there's certain wiring we want to hook up. I'm going to remove the comments. And so what we want to do is declare our functions, our base class functions as virtual, so there can be overridden in subclasses. So I'm going to make start a public virtual, and likewise update. Save that. One thing I like to do with most of my classes is give them a public boolean called debug. This creates a little checkbox in the inspector that you can just turn on and off, and you can then debug information, draw lines, AI, etc., crap like that. So now we think, okay, what kind of properties do we want units to have? What properties will be common between units and players, or units and AIs? Basic navigation stuff. So we'll start with some public floats, make them public so they're tweakable in the inspector if we want to change them. I'll make a walk speed, initialize it to 1. I'll copy that line, Control-C, Control-V. I'll make a run speed, initialize it to 5, and then finally a turn speed, which I'll initialize to 90. Now, so this is our unit-based class, just about ready to go. If I drop back to Unity, click on my player, and try and assign that unit class, you'll see I can't add script behavior unit. The class can't be the script class can't be abstract. So this is that preventing you from instantiating just a unit. So we need to create a subclass of unit. So I will create a new C# script and call it unit player for player controlled units. Open that up. All right, so to correctly subclass this, we want to replace mono behavior with unit. And I'll get rid of these comments. And now, to correctly override these, we want to declare these as public override, and be sure to call the base versions of these functions. So I'm going to call base start, and I'm going to do the same for update, public override, and call base update. Right now, our unit start and update aren't actually doing anything, but they will probably in the future. So we just want to make sure that that wiring is all good to go. Okay, now if I drop back to Unity, oh wait, here, let's do something else first. I'm going to back up a bit here and just redo some stuff here. The first thing I'd like to do is put all my Brengine classes into a namespace called Brengine. This just helps organize code and make sure that you don't get confused as to what classes are in what namespaces. So I'm just going to go namespace Brengine and wrap the whole class in that namespace like this. Like so. Okay, now I can redo. Now I'll do this here. This is just for the stream edit, not to worry. A lot of growing pains here as I get this dialed in. Voila. And I'm going to put the unit player class. Oh, now in your case, if you're going to be overriding Brengine classes, you'll want to specify your namespace this way. But because I'm going to put unit player in the Brengine namespace, I just need to do this. There. Now Brengine is now unit player is part of the Brengine namespace. All right. Unit player will use character controller to navigate. So I'm going to add a require component so that when we add this script to a game object, the character controller is automatically added. The way you do that is just before the class declaration, you go require component, type of character controller. Whoop. Character controller, like so. Now if we drop back to Unity, click on our player, put the unit player script on it, and you see the character controller is automatically added. I'm going to move the unit player script up to the top. I like my scripts at the top of game objects just so they're easy to see. If we look at it from the side, you can see that the controller is embedded in the ground. So what you want to do is set its center to 0.1. Also, because we scaled the capsule, it's a little wider, so I'm going to drop its radius down to 375, which is just big enough here, 0.375. There we go. All right, that's good to go. Let's jump back into unit player. We'll want a private reference to that character controller. I could make it public and assign it in the inspector, but I'm going to get it in code, so there's less things that a designer needs to be concerned about. After we call, actually I'm going to do this in awake. So let's copy the start function, do it in awake so it gets acquired right away, as soon as the object's created. So I'll just basically copy the start function, change it to awake, and then I get a complaint because I haven't set up the virtual in the base class. So let's drop over to unit and add that virtual awake. Like so. And the errors go away, very nice. So now right after I call the base awake, I'm gonna go controller equals get component character controller. There we go. And we'll just drop into Unity and make sure that's happening properly. You can see because it's private, it doesn't appear in the unit player inspector, but if I go up to the little hamburger and turn on debug, now we can see the hidden variables, the private variables here. They're read-only, but you can see them. So if I run now, I can see that right at the beginning when awake is called, a reference to the character controller is acquired. All right. So let's go to update. We want to get input vectors from the input system. If we go to Unity to look at the preferences, you go edit. If we go edit project settings, input, open up these axes, we'd see all the predefined axes. The ones we're interested in are horizontal and vertical, and we can see that by default, the horizontal axis is associated with left and right on the negative and positive axis, and A and D as well as the alternatives. So this means that when I push down the left button, I get -1, and when I push down the right button, I get 1. Likewise A and D. So that's for X movement along the X axis of the player, left and right. Left and right. And vertical we'll use for forward and backwards. It's associated with down and up and S and W. So we will use the vertical axis for movement forward and backwards. So what we want to do is get those axes and put them into a movement vector in code. We'll do that in update. I'll go move. We'll put them into a vector 3 called input. And we'll go create a new vector 3 whose X parameter equals input dot get axis called horizontal. Nothing on the y. And then the z value is input dot get axis vertical. Like that. This will take the value of those axes, -1 to 1, depending on which keys are pressed, and put them into the x and z of our input vector 3. We can immediately go controller dot simple move and pass that input vector. If we drop into Unity now, just look down at our player from behind here. Let's see. There I'm moving. Forward, right, backwards, left, like so. Oh, got a doggy emergency. Just a moment. Okay. One thing you might notice if you're keen-eyed is when I move forward, I'm moving at 1 unit per second. Simple move is in translations per second. When I move right, I'm moving at 1 unit per second in all directions. When I move diagonally, though, I'm moving too quickly. My hypotenuse is longer than it should be. One along X and one along Z gets me to a position where that normal there is longer than it should be. So Doom and Quake actually kept this bug as sort of a little exploit that players could use. When you move diagonally, you move a little bit faster than when you're just strafing or running forward. But I like to fix that. So the way you address that is in input. Before you apply the input, you want to normalize that vector. That'll take that hypotenuse and shorten it to 1. Now if I look at the player moving, you could see that the speed is more consistent in all directions now. He's not moving any faster diagonally than forward and backward or left and right. Let's get turning in here. We'll want to get our turning from the mouse's X movement. So if we look at Edit Project Settings, we can see that there is a input axis predefined called mouse X, and it's associated with mouse movement on the X axis. So we'll want to use that to rotate our player. The way we do that, I'll do that. If you turn and then move, you end up in a different place than if you move and then turn. So it's important that we turn and then move for responsiveness. Just going to simply rotate the player's transform around the Y axis based on mouse X input. Transform. Rotate. Nothing around X. Input.get axis mouse X. Nothing around Z. Like so. If I drop back to Unity, now the player is moving on, now the player is turning with mouse X movement. However, you'll notice that if I move, I'm still moving global coordinates. Now, this might actually be desirable for a top-down shooter type game, but I want, yeah, so there you go. You're sort of almost at a twin stick, as it is. However, I want the player to move in the direction he's looking. So before we, what we want to do is, before we apply that input, is translate from local into world coordinates, and use that. You do that using a function called transform vector. That's on the transform. Transform.transform vector, and then pass input. And if we mouse over this function, you'll see it transformed vector from local space to world space. So it says, take the Z movement and apply it to my Z. Convert it to my Z. So now when I move and turn, I move in the direction I'm looking. Or I don't, as the case may be. Why is that? Oh, because I didn't assign it. Oh God, I'm tired. So what we want to do is go input equals transform vector input, like so. And if we look at this function, we can see that it transforms vector from local space to world space. Now when we move and turn, we move in the direction we're looking, like so. Let's get running in. I want to be able to run when I press the shift keys. So we need to define a new vector. So if we look at the input vectors here, we can see there's a jump is predefined associated with space. That's good. We'll get to that. But there's no run. So I want to add a new one. So I go to the size, I increase it by 1 to 19. And now it copies the last entry, cancel. So we'll want to rename that run and associate positive with left shift and alternative positive with right shift, like so. So now we have a vector associated with the left and right shift called run. After I normalize the input vector, or anytime before I move, I want to scale it. So I'm going to go input equals, or sorry, times equals input dot get button run question mark run speed colon walk speed. If you're not familiar with the conditional operators here, question mark colon, it's essentially kind of like a little if else. So if this condition is true, then use run speed, else use walk speed. And that's going to scale the input vector. Times multiply the input vector. Save that. Drop back to Unity. Play. Now when I hold down shift, I run. Like so. Let's get the camera into that head position. Really into the position of the eyes. So what we want to do is get references to the head and the eyes. I could make public variables. And assign them in the inspector. I'm just going to use a property. I'm going to make this a part of unit. So here in unit class, I'm going to go public transform head. We'll have a getter and a private setter. And same for eyes. Then here in awake, I'm going to go head equals transform find child, just find head. And likewise copy that and set eyes to find head / eyes. Alternatively, I could go head.find eyes. I'm using a path here. They're essentially the same. I'm just going to go check in debug and make sure that those are found correctly. Looks good. Excellent. Now back in the code, in unit player, after I do all my turning and moving and all that, the last thing I'm going to do is move the camera into the position of my eyes. And I'm going to do that by going camera.main, which is a reference to the camera tagged main camera, transform.position equals eyes.position, and the rotation equals eyes.rotation. Drop back to Unity. There we go. Camera's moved in the head position, eyes position rather. Camera moved into the eyes position. It's kind of hard to see much of any movement in this world as it's so empty. So I think I'm going to take a moment and throw down a couple of little buildings here. I'm going to create an empty object, call it building. Let's turn off debug here, put this back on normal. I'm going to make sure it's at 0, 0, 10. Actually, we'll go 10, 0, 10. 10, 0, 10. And under that object, I'm going to create a new cube, which I'm going to scale First I'm going to move it up to y 1.5 and then scale it 10, 3, 10, kind of a one-story building. I'll make a a gray material. And throw that on the building. There we go. Now I'll duplicate it, move it to x negative 10, and then grab both of them, duplicate them, Control D again, and move both of those to z negative 10. There we go. Now we got some buildings here. Now if I run the game, it's a little more obvious when I'm moving around now. That's good. Bit of an environment. Let's get looking up and down in. We're going to do that using mouse Y movement and apply a rotation to the head around the x-axis. So let's drop into unit player. I'm going to do this right after turning. Say look up, down. We'll go transform dot. We'll go head dot rotate. And we'll want to apply the mouse Y we'll want to apply mouse Y movement to the head's X rotation, like so. Input get axis mouse Y around the X, no rotation around Y or Z. If we drop back to Unity and run this, now I've got look up and down. It's inverted. If I move the mouse down, I look up. We'll fix that. Also, if I look at the player, you can see right now, as I move the head, I can do this. Oh my God. I can exorcist my head all the way around. That's not so good. So what we want to do is clamp the head rotation by some amount. So let's scroll up to the top of unit player and add a couple of variables. We'll make them public so they're tweakable in the inspector. Public float, I'll call it head pitch min. I'll initialize it to negative 60. And head pitch max, which I'll initialize to 90. The idea being here I can look negative 60 degrees down and positive 90 degrees up. So I can look almost all the way down and I can look straight up. So what we'll do is we'll calculate the head pitch and then clamp it between those two values and then set the head rotation to that. So we want a variable to store our current rotation. I'm going to call it head pitch. I'll initialize it to 0. And then in update, instead of applying that rotation directly to the head transform, I seem to have lost my camera input. Just a moment here, folks. Sorry. There. Hopefully that wasn't out for the last hour. Alright, where the fuck was I? Right. Okay, so now instead of applying that mouse X, so now instead of applying that mouse Y, instead of applying mouse Y directly to the head, we will apply it to, we will add it to head pitch plus equals mouse Y. Don't need the X vector 3 anymore. Then we'll clamp head pitch to our min and max. Head pitch equals math F clamp. The value is head pitch between head pitch min, head pitch max. And then finally, we'll set the head rotation to that head pitch each frame. Head. And we'll want to do it locally. So apply it to the local rotation equals quaternion. Rotations being a quaternion, and we'll use the angle axis function. The angle is head pitch, and the vector is ordinarily it might be the x vector is defined as right or left. If we use left, that's -1, which will fix our inversion. Counterintuitively, looking up is a negative rotation, so if we use the left vector, it will invert that, and now looking up will be a positive rotation, which is a little more intuitive. So we'll use the right vector, or sorry, the left vector. Like so. A quaternion is basically a 4-member a class that encodes and calculates vector rotations in a way that is more efficient and avoids gimbal lock and some issues with vector 3. Quaternions are kind of like cars. You don't need to know how the engine works to drive a car. You just need to know certain functions. And quaternions are a bit like that. The internal mathematics and calculations are very complicated and hard to understand intuitively, like vectors. So all you really need to know is certain functions on quaternions in order to use them effectively. There's only a few. All right, let's have a look at this. There we go. Now you can see I'm looking almost all the way down, and I can look straight up. I'd like to be able to look down and see my body. I think the reason I can't do that right now is because the clip plane, it's being clipped out. If we go to the camera and adjust the near clip plane, I believe that will fix that. I put it to 0. The default lowest value is .01. There we go. Now I can see my body. That's always kind of neat to look down in a first-person shooter. Okay, so now we have pretty close to basic first-person navigation, looking around, heads clamped, I can run. This might be good enough for your game, depending on your design. What's that? Gone Home comes to mind. I believe this was basically as simple as it gets. But I'd like to add jumping. Now, one nice thing about Simple Move is it takes care of gravity for you. Let me illustrate that by making a little ramp. I'm just going to create a cube. I'll throw it at 0, 0, 10, zeta, and scale it to say maybe x3, y3, sure, z9. And then just look at it from the side here in isometric. Rotate it with E. There we go. Just get a bit of a ramp. Now, when I run up this ramp, you can see that I fall. So one thing that's nice about Simple Move is it does apply gravity for you. You don't have to worry about gravity. So gravity's taken care of. Another thing that might be worth mentioning is that Simple Move takes absolute movement deltas per second. So you don't need to worry about frame time or anything like that. However, Simple Move won't allow you to apply translations along Y, which we want to do for jump. However, it also using, yeah, so that's simple move applying gravity for us automatically. So what I'll start by doing is using the move function. Let's have a look at this. Just switching simple move to move. Now when I move way too fast. And you'll notice I don't get gravity applied. So the move, unlike simple move, move takes its parameter in absolute translation per frame. So first thing we want to do is scale it, that input, by time.delta time. If we done that, see? If we've done that, we come back here. Now we're moving back at our correct speed. Frame rate independent. However, we still don't have gravity being applied. We need to do that ourselves. If we want to translate on y, as in jumping, we need to worry about gravity ourselves. Now, gravity is one of those things where the longer you fall, the faster you fall, so we want to accumulate and apply gravity over multiple frames. So we'll need a variable to store that. As well, in my design, I want to, when I jump, I want to keep my x and z velocity so that more realistically. I don't want to be able to move in the air. Some game designs, maybe you do, but I don't. So I'm going to use a variable to store both my inputs and my gravity over multiple frames. So I'm going to scroll up to the top here and add a new private vector3 variable. And I'm going to call it move. I'm going to initialize it to 0. All right, now in my design, I only want players to be able to jump when they're on the ground. When you're in the air, you can't jump. Double jump might be something we tackle in the future. And also in the air, you can't move. You can turn, but you can't move. So here in move, first thing I'm going to do is go if controller is grounded. This is a Boolean on controller that indicates whether you're in contact with the ground. If that's the case, I'm going to do this input stuff. And finally, I'm going to apply the input to move x equals, finally I'm going to apply the input to just the move x and z values. So I'm going to go move.x equals input.x and copy that line. Move.z equals input.z, like so. And then down here in the controller move, I'm going to replace input with move. Now we'll want a velocity for our jump speed. So I'm going to drop back to unit and copy the turn speed and call it jump speed and initialize as something, say like 10. Then back in unit player, after I've applied the input to the move, I'm going to say if input.get button down. Jump being predefined and associated with space, remember? If this is the case, then move.y equals jump speed. If it's not the case, then I want to apply a little bit of gravity. So I'll go move.y equals physics.gravity.y. Basically, if I jump, apply my jump velocity. If I don't jump, just apply 1 frame's worth of gravity. You should do this every frame to keep you in contact with the ground. As you go down a slope, you want to stay in contact with the ground. Otherwise, is grounded tends to oscillate, and that's not ideal. You'll miss jump presses and things like that. So just applying a little bit of gravity here will keep you in touch with the ground. If I'm not in touch with the ground, then I should accumulate gravity. So move.y plus equals physics.gravity.y times time.delta time. And I should actually, mistake, I should scale this one as well by time delta time. That way, gravity is applied per frame and accumulates per frame too. Make sure that's a plus equals on the else to apply that gravity. I think that's it. Let's drop back into Unity and see how this looks. Whoop, oh, that's a big jump. It's a big jump. However, you can see as I jump, I can't change my movement. So I keep moving the direction that I started my jump in, but I can look. I can look around, so I can do cool kind of matrixy jumps, but I can't really steer in space, as it were. That jump is a little ridiculous. Let's turn that down to maybe 5. Jump speed 5, very good. Save, run again. That feels a little better. Yeah, there we go. One final thing I think that's worth noting in our code, in the mouse movement, you might want to, instead of using get access, you might want to prefer to use get access raw for both the mouse X and Y. Get access raw gives you just pure mouse deltas with none of the smoothing that Unity applies to these input vectors. I like them on things like horizontal, vertical. You get, kind of acceleration and deceleration effects. We can tweak these maybe in a future video and talk about those specific values in more detail. But for mouse input, I prefer to have just the raw deltas with no smoothing applied. Makes it very snappy and responsive for aiming and things like that. There we go. I feel like that's it. We've got basic first-person character controller-based navigation using move and simple move with run and jump, and it feels pretty good. I think that'll do it for this one. Thanks a lot, folks. Let me just have a little poke. I'm sure everything's cool. Any comments? No.